Okay, so the next thing we're going to take a look at, we're still looking at ionic compounds, but this time we're going to add what's called the stock system. And if you've looked through the PowerPoint, you've seen that here's where those transition metals are going to come into play. This is a different periodic table, but you see that a lot of times these transition metals, and a couple over here in groups 13 and 14, they can take on different charges. And it all has to do with those valence, those outer shell electrons, that they can kind of go into some different energy levels for different reasons. And the state of Tennessee is going to give you those on this chart. And this is really small, so I don't expect you to see it, but I want you to see that they're all listed right here, the ones that the state's going to ask you over. What I have given you in class is just that periodic table again that shows you, but the main thing you need to be thinking about is when you look at something that's ionic and it has a metal from somewhere in here, then you're probably going to be using the stock system. And if you've looked at some of those examples, you realize the stock system is where you can have an element that has multiple charges. So let's take a look at copper 2 oxide. We see this 2 right here, and students are always like, what in the world? Why is there a Roman numeral there? Well, that Roman numeral is to tell you what the charge is on the copper. Okay, if you look at your sheet that looks like this, and you find copper, fourth one down, you see that copper can actually have a charge of +1 or +2. So here, what I'm telling you right now is that copper can have a charge of +1 or +2. Well, if you're trying to make a chemical formula, how do you know which one it is? And that's where this Roman numeral right here comes into play. That Roman numeral of 2 is telling us that this copper is the copper that has a +2 charge. And of course, we know oxide is oxygen and that it has a -2 charge. And so what would be our chemical formula here? The +2 and the -2 are going to cancel out, and we would just write that as CuO, which is what we've been doing. Let's take a look down here. Again, we understand that copper can be a +1 or a +2. So how do you know which one to use when you're coming up with a chemical formula? Look at your Roman numeral. Your Roman numeral is telling you what the charge is on that metal. So in this situation, that copper has a Roman numeral 1, so we're going to put a Cu with a +1 to represent that +1 charge. And then, of course, we just said that oxygen has a -2 charge. And so our chemical formula here, how do we get the -2 to cancel out? We're going to need 2 coppers. So we're going to bring in a subscript of 2 and, of course, 1 oxygen there. This next one, we see a Roman numeral of 4. And this is one of those points that if you don't know your Roman numerals, you only need to know the first 4. We've got 10, and this is also why Ms. Vaughn had you memorize certain elements. We know that 10 is represented by an S and an N. And what did we just talk about? Hit the pause button. Think about this. What does that Roman numeral right there represent? It is telling you that the charge is a +4. 10 is a stock element. So if you look back over here at your chart and you find it, you see that 10 can actually be a +2 or a +4. So how do you know what the charge is? Look at the Roman numeral there. Sulfide is simply sulfur, which we know has a -2 charge. And now you've got to look at this and say, okay, I have a +4 and a -2. How do I get this sulfur to cancel out with a 10? Well, I need 2 of them. So your chemical formula would end up being SnS2. And those right there, again, some of the basics. Let's take a look at a couple more, and then we're going to look at the other side of this. We have iron 2 nitride. If you look at your little common ion sheet there, iron can be a +2 or a +3. So we have Fe here. It can be a +2 or a +3. How do we know which one it is? The Roman numeral tells us that it's a +2. Nitride is just nitrogen, guys. Don't try to confuse that. It's just that IDE. It's just nitrogen, which we know has a -3 charge. And again, we're trying to get those charges to cancel out. Lowest common multiple here would be 6. So you're going to end up with a subscript of 3 on the iron and a subscript of 2 on the nitrogen. 10, we discussed earlier. Symbol is Sn. That Roman numeral is a +2. This is just oxygen, which is a -2. So stop right there and think about what I just did. Hit the pause button. Go back through what I just did. Do not complicate this. It's telling you the charge From there, you find the chemical formula. Those cancel out, so we don't need to add any subscripts here, and we would just end up with SNO. And the last one, students always get a little confused because that looks kind of like magnesium at first glance, but that's actually manganese, which is a transition element. We see that Roman numeral 3 there, which means that it is a +3. And then we've got selenide, which is again one we don't use that frequently, which is Se. If you look at your periodic table, selenium is right over here in group 16, which means it has a charge of -2. So it's going to look a lot like this one up here. We're trying to get the charges to cancel out. In order to get to 6, I'm going to multiply this one times 2, this one times 3, and then whatever you multiply by, that becomes your subscript. So we end up with a subscript of 2 on the manganese and a subscript of 3 on the selenium. Okay, so there I gave you the name and had you come up with the chemical formula. But if you look down that Canvas page, let's look at when you're given the chemical formula and asked to come up with the name. Give me just a second here. Okay. So these are a little bit different. Let's talk about how you know when I need that stock element. And this is a good example here of when that's going to happen. Notice right off the bat here that we have Hg, which if you remember the elements is mercury, and we see here bromine. So in your head, what you see is a metal and a non-metal, okay, which is good. And give me just a second here. I'm going to zoom in just a tiny bit. We see mercury and we see bromine. So we see a metal and a non-metal. And so you're thinking mercury bromide, which is what we talked about yesterday in the ionic compound video. But pay attention to that mercury. Mercury is a transition element, and it does, it does some pretty crazy things right here. It actually can take on multiple charges. And if you look back here at the back of your table and you find mercury, you see it can have a +1 or a +2 charge. And so now we're sitting here and we know that this is supposed to be mercury bromide, IDE, okay? But the question is it a +1 or is it a +2? And how can we figure that out? How do we know what Roman numeral to put right here? Well, we have to look back up here. You've got a bromine. And think about one individual atom of bromine. What kind of charge would it have? It would have a -1 charge. And we're trying to figure out what this positive charge is over here on this mercury. Well, pay attention to that subscript right there. You've got 2 bromines. You have 2 bromine atoms, each one at a -1 charge, which means what does the charge have to be on that mercury? Because you only have one of them. It has to be a +2. -1 and -1 is -2, so that overall charge over here is a -2. The only possible charge here is a +2. So the Roman numeral that I'm going to put here is that Roman numeral 2 to indicate that it is definitely a +2 charge. Let's take a look at the next one. Here we see iron and we see oxygen, which we're going to rename Oxide because it's an anion. It's going to go to IDE. And again, you're like, oh, I'm done. Iron oxide. That was easy. But iron is a stock element. It's one of those that can have multiple charges. If you look at your chart, it can be a +2 or a +3. So we're trying to figure out, which is it? Is it a +2 or a +3? Well, if you're not sure, let's come over here and let's rewrite your cation and your anion. We know without a shadow of a doubt that oxygen is -2. And notice that you only have one oxygen. We're trying to figure out the charge on iron. And notice that there's only one iron here. So that means that this has to be a +2. A +2 and a -2 would cancel each other out. So over here, I'm going to write in a Roman numeral of 2. And that would be iron 2 oxide. Maybe take a moment right now and pause the video, see if you can work out this next one on your own. If not, just kind of follow along with me here. Ni, if you remember back to your elements, it represents nickel. And then we have oxygen again, which we understand is going to change to oxide. And you'll get better with these and recognizing when they have multiple oxidation numbers, but ultimately, if you find nickel, it's over here again. It's in that D block. It's one of those transition metals. And we see that nickel can actually have a +2 or a +3 charge. So I'm going to write that down here just to kind of try to figure out what is this charge, what's the Roman numeral on it. Notice that you have one nickel atom. We know that oxygen has a -2 charge, and you only have one oxygen atom. So that means that the charge over here has to be a +2 because they're ionic. They are absolutely going to cancel out. And so that one would be nickel 2 oxide. Next up here we have Cr, which represents chromium. And you've guessed it, it is definitely a stock element. And we see iodine, but again we're going to change that to iodide, IDE, because it's an anion. If you look at your chart, you see that chromium can be a +2 or a +3. So we're trying to figure out what Roman numeral is going to go there. Is it a 2 or a 3? I'm going to go ahead and write chromium as my metal. And think about iodine. What do you know about iodine? You know that it has a -1 charge. Okay, if it's just one iodine atom. However, look over here at your chemical formula. You actually have 2 iodine atoms. So when we look at the iodines, what's the total charge on the iodines? A -2. Which means, what does the chromium have to be in order to cancel out that -2? It has to be a +2. So we're going to put in our Roman numeral of 2 right there. Next up, I'm running out of space here, sorry. You see Sn, which we know is 10, and we've already mentioned it as one of our stock elements, and then that's sulfur, so that would be sulfide. Change that ending to IDE. If you look at 10, you're going to see that it can either be a +2 or a +4. Think about what we know. We know that the 10 is the metal, so it's definitely positive. We know that one individual sulfur atom is a -2. But notice that you have 2 sulfur atoms here, so we actually have a second sulfur atom with a -2 charge. Well, what's your overall charge on your sulfur? A -4. -2 and -2 is a total of -4. You only have one 10 atom. So what does the charge have to be on this 10 in order to cancel out that -4? A +4. And so we would come over here and we would write that in. So that's the same problem we worked earlier. It's just looking at it a little bit backwards. Okay, 2 more. Iron oxide. This is one that you're going to see multiple times throughout this semester. We see iron, and then of course we see oxygen, and we know that that is oxide. Do not let this one confuse you because of these subscripts. Notice that I am currently ignoring those subscripts. When we look at iron, we see that it could be a +2 or a +3. It's a stock element, so we're trying to figure out which one it is. We're going to go ahead and list that iron as positive. We don't know what the charge is yet, but we do know that it's the metal and it's positive. And we know without a shadow of a doubt that one oxygen atom is always a -2. Well, this is where, now look over here. How many oxygen atoms do you have in this? You actually have 3 total oxygen atoms. 1, 2, 3. And each oxygen atom has a charge of -2. So what's the total charge here on that oxygen? A -6. Notice over here you have 2 iron atoms. So I'm going to draw another iron atom down here. This is -6. What has to be the charge on these iron atoms in order to cancel out with that -6? A +3 on each one, because +3 and +3 would be +6. +6 and -6 would cancel each other out. So here's a case where we have iron 3 oxide. And again, you will see that one multiple times. Last one on this tutorial is nickel. So we're going to go ahead and write out the word nickel. And then we see phosphorus, which we understand is phosphide. And same thing as last time, we know that nickel is the positive cation because it's the metal. It's going to give away electrons. And then we do know that phosphorus is in group 15, which means that it has a charge of -3. Now again, pay attention to your chemical formula here. You actually have 2 phosphorus. So I've got 2 atoms. What's their overall charge? A -6. Notice over here on the nickel, how many nickel atoms do you have? You have 3 nickel atoms. Okay, and if this is a -6, we know that this adds up to a +6. So what does that mean the charge is on each one of those individual nickels? A +2. So a total plus 6, which means the nickel has to be nickel 2 phosphide. And again, think about what that Roman numeral means. That Roman numeral is simply telling you what the charge is. Practice these. They are not that difficult, but you do have to practice them.